lesson done. Elimination. So, when you hear the word elimination, what do you think? To kill, get rid of, terminate, yes. Okay, so if you eliminate something in math, would it equal to 0 or would it equal to 1?
Subtract.
0. Okay, guys, you with me? Here are the steps. Okay, so if necessary, multiply each equation by a constant to obtain a coefficient for x or y that's identical, except perhaps the signs. So what we want to do is everything has to be aligned, first of all. It doesn't say that. So our equations need to be aligned. So what I mean by that is they have to be in the same order. The x, and then the y, and then the equal sign, and the constant should all be in the same spot. Notice the equation down here. Is everything aligned? If you have two, yeah, the x's line up, the y's line up, the equal signs line up, and the constant line up. They all have to be aligned. Now this one, the first step is already done, because our goal is to make either the x coefficients the same or the y coefficients the same. Okay, it doesn't matter about sign, just the actual number. Is that already done for us? Yeah, y's both have a coefficient of 7. Okay, so then our next goal is going to be to add or subtract depending on the sign. Because our goal is to eliminate that variable where the numbers are the same. We want to make 0. So in this case here, would we add the equations or subtract them to eliminate the y? If you have a +7 and a -7, they're already opposite, so you would add the equations. If the signs are opposite, we're going to add because we want to make 0. So would you agree that 7 plus -7 equals 0? Yeah, if I would have subtracted, what happens if you subtract a negative? 7 minus -7. It turns into 14 because it turns into plus. So 14, right? Because if you subtract a negative, it would have been turned into a positive. That's why it's not subtraction in this case. So only if the signs are the same do we subtract. Okay. Well, okay, 2x plus 3x. Let's add these equations together. 5x. What is 7y? Come on. Plus -7y. 0. Cancels out. It's eliminated. Pew pew. Gone. Okay. 13 plus 2. Sorry. I have a 3-year-old son, okay? That's what I do all day. 15. And now, just divide by 5.
Oh, I like this.
Yeah, I know, the first equation. X equals 3. From this point forward, everything will be the same as substitution. Okay? Maybe. Okay, so now that I know that x is 3, guys, I need to find y. Now, the benefit of substitution is we already have an equation that would have been y equals, because we would have rearranged it. We didn't rearrange here. So, does it matter who I plug in? X is 3? No, into either equation. So let's do the first one. Sub x equals 3. Let's do into 1. It doesn't matter which one though, but let's do 1. 2 times 3 plus 7y has to equal 13. Okay? Everyone see what I did there? So I took my answer of x equals 3 and I subbed x equals 3 into that first equation. I replaced the x with 3. So just right here. The x I replaced with 3. 2 times 3 is 6. Next step would be to subtract 6, which gives you 7. Divide by 7. Y is 1. Okay? And then you still have to do what? Your check. You still have to do your check. Yeah, let's do it. Yeah. No. No, I wasn't. Maybe. Okay, so checking. We're just going to do this really quickly. 6 plus 7 is? 13.
What? Oh wait, I see it. 7 plus 7. I was like, where did you get the 6?
Oh. And then 6. Wait. Uh-oh. Oh, 3. X is 3. See? Silly mistakes. This is what happens when you rush. Lesson. Lesson, guys. Learn from my mistakes. 9 minus 7 is 2.
I want to know what other mistakes could have been.
I've made lots of mistakes. Yeah. I don't know if I said made lots. Yes. Boys. That's what I regret. Okay, funny story. Maybe later.
You can't do that.
Yeah, I can. So let's look at this next guy. Sure can. All right, we're ready to go. Do we have 2 variables with the same coefficient? Yes. Now this time they're the same sign, right? Everything should be aligned. Is it all aligned? Yes. So we're going to, Ishpal, subtract. Okay? So why would we subtract? Because of the same sign, so in order to make a 0, you have to subtract it. 2 minus 2.
So if they're not the same signs, then you add. If they are, then you subtract.
Exactly. If they're not the same sign, we add. If they're the same sign, we subtract. Now here's my advice to you. Remember polynomials when we subtract polynomials?
Yeah.
What did I tell you to do to make it so that you don't make a mistake? Yes, we want to change it to addition by switching the signs. Okay? So, if you do not trust yourself in the terms of subtraction, especially when it comes to subtracting negatives, we can add the opposite signs. We can switch the signs and then add instead. Okay? So I'll show you both. So let's say if we just left it as subtraction. 2 minus 2, 0. 6 minus 3, 3. Whoa. I don't know why that happens. Do I? 6 minus 4 and a half. What? Subtracting. See, that's why if instead of subtracting, we can add, we can switch the signs and then add them. Okay? So if you're not confident, switch your signs so that they're opposite and add instead. Just all of them. Okay? So does that still give you 3y equals 1.5? Yes, it does. Both would work. These would still cancel. Okay, divide both sides by 3, and what does that equal? 1/2. So y is a half. Yay. Okay, I don't only have to write this once. So I just wanted to show you subtraction versus adding the opposite sign. Same thing. No. So this is just or. Okay. All right, now we need to find, now what? Find x by subbing half. Does it matter into which one?
No.
No. Let's do the, 2 times x plus 6 times half has to equal 6. So I subbed y equals a half into the first equation. 2x plus half of 6. Ryan, I think you need to move back up. Are you guys? So 2x equals 3. Divide both sides by 2. Okay. I'm going to skip the verifying. I know. So bad, but we talked. Okay. Let's move on. There's still a lot I want to go through. That's why. Now, is life as easy as the previous page here? No. So we either need to make the x's the same or we need to make the y's the same. So who do you want to make the same? X? Actually, they're both just as easy. Okay? So our goal is to have opposite signs so that we can add. Really, y might be a little bit easier. Okay? So what we want to do, they want us to make the y's the same because they say multiply the second equation by 3. So what we're going to do is we want to make this the same, so I can multiply this entire equation by 3. So that y turns into a minus 3y. But you have to multiply everything. It's an equality statement. So if you triple one side of the balance beam, you still have to triple the other side of the balance beam. And then it's still the same weight, right? So our equations are going to become 2x plus 3y equals 4 and 12x minus 3y equals 66. Now, where do you think students make the biggest mistake here? Nope. Nope. I'll see all this work, and then I'll see this. Don't forget to multiply the other side. So that's where the biggest mistake I find is with elimination. You have to keep equality. So don't forget to multiply. Both sides are going to be multiplied by 3, right? The whole equation is multiplied by 3. All right, so are we adding or subtracting if the signs are opposite? Adding. 2 plus 12. 14. Negative 3 and positive 3 make? Eliminated. Pew, pew. You're going to have that going through your head tomorrow or during your quiz. 66 plus 4. 70. And next step? Divide by 14. 5 times. Okay. And last, not last, we still need? Nope. We need y. We have x, but we don't have y. Poor y. Okay, does it matter which equation? No. So let's do the first. 2 times 5 plus 3y equals 4. And plus 3y equals 4. 4. Next step. Minus 10. 3y equals negative 6. Y is negative 2. Divide both sides by 3. When you check, where do you check? All the originals. So you can't use your manipulated ones. You have to go back to the original, okay? Can I skip the checks just for time's sake? Yeah. All right. Let's look at this guy. I love this question. Consider the system 5a plus 3b equals 3. 3a minus 7b equals 81. Now, first off, is everything aligned? Yes. So they've been nice to us so far. Do you think they're going to be that nice in your homework? Mostly. Let's see. Not always. Not always. Okay. Oh, Thank you.
Well, you got all the chair.
All right, so we want to make the A's the same, or we want to make the B's the same. Is there one that's easier than the other? Okay, so first of all, the A's. Is 1 a multiple of the other? Is 5 a multiple of 3? Sure not. Okay, so if I wanted to make the A's the same, what would I have to multiply the first equation by? 3, and the second I'd have to multiply by 5. Okay, you don't have to write this down. Just let's talk. If I wanted to make the B's the same, what would I multiply the first equation by? 7 to make 21. And I'd have to multiply second equation by 3 to make 21, because one's not a multiple of the other. So we're going to have to change both equations. Now, who do you want to do? They said B. So let's do 7 and 3. Okay? I like to choose ones that are opposite sign, because then automatically we're going to add. And adding, you're less likely to make a mistake. Right? So, what is this equation going to become if I multiply the first by 7? 35a plus 21b equals 21. Don't forget the constant. It's the biggest mistake. And sometimes just pointing out where the biggest mistake is will help you kind of be aware of that when you're doing your work, right? Hopefully. The second equation will become 9a minus 21b equals, thank you, 243. 200, yeah, 24. 240 plus. Okay. Let's skip this. Okay, so because the B's are now the same coefficient, so it will work that if you just switch the numbers, it'll work every time. So 1 had a 3, 1 had a 7, so 7 and 3. Now, usually we want the lowest common multiple. Like if I had, give me a second. Let's think 12 and, I don't know. Usually, you have to do both. It's probably the easiest way. Yeah, in the end, it'll all work out the same. Yeah, you just might have bigger numbers, but it'll always, so if you have to just even just switch them, it'll work every time. Okay, so we are adding 35 plus 9. 44. B's are pew, pew, eliminated. Equals 200 and... Did I make a mistake? No. Yes, I mean, I just added one. 64. So A, divide both sides by 44. A is what? A is 6. Okay, so when I find B, it doesn't matter which equation I sub into. I like to usually go back to one of the original ones because the numbers are smaller. You could use one of your new ones if you wanted to. But the numbers are smaller. So let's use, I don't know which one. First or second? Second. Okay, 3 times 6 minus 7b equals 81. 7b? I'm using this original equation here. It doesn't matter which one though. 18 minus 7b. Next step. Subtract 18. 81 minus 18. 63? Come on. Be nice to me. There you go. And divide both sides by negative 7 is negative 9. Okay. When we verify, where do we verify? The original. Okay. Yes, let's move on. I'm not verifying again. I'll verify one of these ones. Okay. All right, solve. It doesn't even say verify. Yay, I'm not a hypocrite.
Wait, on a test if it says don't verify, that we don't have to verify?
Your written response will always say verify. But multiple choice numeric, it won't. However, verifying does tell you if you're right. And it tells you if you made a mistake. Okay, do these equations line up? Are they aligned the same way? No. So I like to go x, y equals constant. So this guy would become 4x plus 2y equals what? Nope. Positive 13. So we're going to add the 13 to the other side. So let's make x, y constant. So that gives me 4x plus 2y equals 13. This guy, what would I have to do to make it align the same way? So subtract the 5y so that we have x and y on the same side. 3x minus 5y equals 26. Okay, so we have our two equations. Now before we line them up, let's ask ourselves, who do you want to eliminate, x or y? Okay, so why did you choose y? They're already opposite signs. If you look at the x's, is one a multiple of the other? No, so I'd have to multiply this equation by 3 and this equation by 4, right? Are one a multiple of another? No. So I'm just going to have to multiply this equation by 5 and this one by 2. Okay? And they're opposite signs, so this way we can add instead of subtracting. Do you want to do the x's just for funsies so we have a subtraction example, or are you okay? You ignore the sign. Ignore the sign, so we just worry about the actual coefficient. So 5, and this one will be 2. So I'm going to write them over to the left now. When I multiply that equation by 5, what does it become? 20x plus 10y, and don't forget 65. Don't forget the coefficient. Multiply everybody by 5. So if you want, maybe want to write it a little different in the sense of, oops, when you write this here, I'm going to erase this. You need to write times 5 times 5 times 5 times, get rid of those brackets, times 2 times 2 times 2. So you remember to multiply everybody by 2, everybody by 5, right? What you do to one side, we do the other. So the other equation becomes equals 52. And so because we have a plus 10 and a minus 10, we are going to add. Okay. But then they said no. But I can do that one if I can show you after. 20 plus 6. The y's equals 117. Divide both sides by 26. Is it a fraction or 9 over 2? So you have to go math, enter in your calculator. 117 divided by 26. Okay, now y. Where do you want to sub them in? You can go back to the very originals. We can also go back to these originals before multiplied by 5 or 2. Really doesn't matter. This one? First or second? Sure. Second? Doesn't matter. Pick an equation. 3x So 3 times 9 over 2 minus 5y equals 26. Don't be afraid of fractions. The truth is you have nothing to fear because you do have a calculator in front of you. 3 times 9 over 2 is 13.5 or 27 over 2. What's next? Subtract. If you want to leave that as negative 13.5, you could have done that as well. Okay, so now 26 minus 27 over 2 is 12.5 or 25 over 2. Negative 5y equals 25 over 2. And then last step, divide, because it's negative 5 times y, we're going to divide both by negative 5. So answer, divide by negative 5. And then to change that, oh look at that, it's already a fraction. So y equals negative 5 over 2. Okay. You want to leave that as a decimal. These decimals are fine. You could have answered as a decimal, only because it was terminating. So if you want to have 4.5 as one of your answers and negative 2.5, that's okay. Okay? But if it's a repeating decimal, sorry, you gotta leave it as a fraction. All right. Oh man, it's warm in here, right? Maybe it's just me. No. Well. Don't be afraid of fractions, guys. Are you, though? Okay, but let's just look at your homework 9A for a second. Look at 9B. Yeah. 9A or B. I know this. We kind of need to look at this, guys. No, okay, let's look at your homework. So, when you get to number 9, okay, 9A is in your homework. So my recommendation is when you approach something like this, is get rid of the fraction first. So just worry about getting rid of the fraction. So I'm going to look at 9B for a second, so that you know you have a guideline for 9A. Okay? So if I look at the denominator 2 and 4, what would I multiply this equation by to get rid of the fraction? What's the LCD of 2 and 4? Lowest common multiple, or LCM? 2 and 4. Lowest common multiple. Smaller. Lowest multiple. 4. Okay, you've been saying 4? Sorry. Okay, so we're going to multiply, we're going to get rid of the fraction. You're going to multiply, so essentially what we're doing is we're going to multiply each term by 4. Okay, each one by 4. What would I multiply each one by in the second equation? 4 and 5. What's the lowest common multiple? 20. So we're going to multiply each one by 20. Okay, so that's essentially what you're going to do with this A example, is get rid of the fraction first. So remake the equations. We'll worry about making the coefficients the same later. Let's just get rid of that fraction. 4 times m over 2. Okay, nope. 4 times m over 2. It would be 2m because it's 4 over 1. Okay? Or you can think of it like we're simplifying here. 4 divided by 2 becomes a 2. So that would be 2m. What happens with the 4's here? If you're multiplying by 4 and dividing by 4, they're going to cancel. You're just going to be left with n minus 4 equals 8. It's kind of tough because that one had a binomial. That's okay. Okay, 4 times 3 over m. What does the 20 divided by 4 reduce to? How many times does 4 go into 20? 5. So it becomes 5 times 3 is 15m minus 20 divided by 5 is 4. So 4n equals 80. No. The heat's getting to me. 5 times 20 is pretty simple. Okay. So that's your first step. Then you can worry about simplifying and making things align and getting the same. So in this example that's in your homework, what would I multiply everything by here? Getting rid of the fraction. Look at the denominator. There's only one denominator. 2. 2 is the only denominator. So you're going to multiply everything by 2. So 3 times 2 is going to make 6. Minus a half times 2 is 1. The 2's cancel. Just 1y equals 10. Good. What would I multiply everything by here? 12. Right. So multiply everyone by 12. If you have to use your calculator, use your calculator. 12 times a third. 4, because 12 divided by 3 is 4. 12 times a quarter. 3y equals 36. Okay? Get rid of the fraction now. It's easy to make them one of them the same. Yes. Okay. All right. So your assignment is circle the following. Let's get a highlighter. 1 AC and 2 AC. 1 A and C. So these ones are nice because they're already ready to go. Which is nice. 2 A and C. Again, these ones are pretty much ready to go. Just have to subtract or add the opposite. 3, 4, and 5 C. Just C. So 3 C, 4 C, 5. Now this is the minimum. C, remember that. 6, all of it. 9A, we've already started. 10, 11. Okay? So you want to make sure that you get the homework done from yesterday and today. It's a big portion of your quiz on Thursday. Tomorrow's lesson short, simple. So we moved things around. I'm glad we did.